Hi, I'm Rachel, and I'm here with the Econ Tutoring Center. And today we're going to be going over relative and cumulative relative frequencies and how to find them, discrete and continuous data, constructing frequency distribution with groups quantitative data, and contingency tables. So the first thing we're going to be going over is like what relative frequency is and what cumulative relative frequency is and how to find it. So you want to find your relative frequency. So the first thing you want to do is you want to find your frequency, which is the amount of time something has happened, and put it over the total. So I'm just going to write that down right here, just in case you forget. So you want your frequency over your total. And that's how you find this. For the probability of something like being 0, you'd put the frequency, which is 5, over the total, which is 50, right here. And then you'd put that in your calculator, do that in your head. That's equals 0.1. And then this would be 8 over 50, because the total doesn't change because it's the total of that thing, all the frequencies. So that would be 8 over 50. It's also 0.16. And then it is 14 over 50, which is 0.28. And then 13 over 50, because the frequency of that one is 13, and that would be 0.26. And then 6 over 50, which is 0.12. And like I said, you're just putting all these numbers for each row because it's the frequency over the total. So nothing is changing in this entire column besides the frequency, because the frequency is changing. So the next one would be 4 over 50, which is 0.08. And then this bottom column is the relative frequency of all of these happening. So that would just be the total of all of it happening, which is 50 over 50, which is 1, and it should equal that because it's like all of them. So that kind of brings us up into our next concept, which is cumulative relative frequency. So how that works is when something is cumulative, it just is like added on and added on and added on. So the first column is the frequency of something happening, of someone buying like 0 of something. So like again, since 0 is the top number, it's just going to be that frequency. So that'll be 5 over 50, which is 0.1. This next one would be the frequency of not only like someone buying 1 of it, but someone buying 0 of it as well. So it would be this frequency, which is 0.16, plus the one above it, which is 0.1. So it's cumulative, so it's just like accumulating. So that would be 0.26. This third one would be accumulation of the first 3, which would be 0.1 plus 0.16 plus the frequency of this one, which is plus 0.28, which is 0.54. This next one of 3 would be an accumulation of all 4 of these, which would be 0.1 plus 0.16 plus 0.28, which we already know is 0.54. And then we just add on 0.26, which would be 0.8. And then the next one would be an accumulation of all these 4 above, plus the probability of it happening 4 times, which would be 0.8 plus 0.12, which equals 0.92. And then this last column is the probability of it happening 5 times plus all the ones above it. So it's like 5 or less. And because this is the last column, and it's the accumulation of all that happening, this is all of your data in general. So the number you should get should be 1 because it's 100% of it happening. We're just going to do the math anyways. So that would be 0.92 because it's an accumulation of these 4, which we already know is 0.92, plus 0.08, which I said equals 1. So a good way to check this is to make sure as you're going down the table that each of these numbers you're getting is not less than the one above it. If the number you're getting is less than the one above it, then that's not making sense because it's an accumulation, so it has to increase. So that is how do you find your cumulative relative frequency. And then there's like a few questions I'm going to go over real quick now that we've like found how to do everything. Another way to think of frequency is just a percentage of something happening, like a probability, which you always think of as like in percentages. So the first question is, on what percentage of days were exactly 4 iPads sold? So this column right here is showing how many iPads were sold in a day. So we're going to look where 4 iPads were sold, which is down here in this column number 4, because that's how many were sold that day. 6 were sold that day. And because we want to find the percentage of how many were sold, that were like how many were sold, that would be this column. It's the relative frequency, because it's not, and it's not the cumulative relative frequency, because it's not asking for an accumulation of all the previous numbers. So that would just be 0.12. Sorry, this is a 0.12, which equals 12%. And how you find percentage is you just multiply that number by 100 or move the decimal over 2 places. So the next question is, on what percentage of days were more than 3 iPads sold? So this question is asking, on what percentage of days were more than 3 iPads sold? So first thing you want to do is you want to find the cumulative relative frequency of 3 or less iPads being sold. So you're going to do that by going to this column, and where you which says 3 being sold, you'll go across to your cumulative relative frequency, and that's 0.8. So that means there's a cumulative relative frequency of 3 or less iPads being sold. But the question is asking, what is the percentage that more than 3 iPads were sold? So because the probability of everything happening total is 1, you're going to take 1 minus 0.8, which is the cumulative relative frequency of 3 or less iPads being sold. And you're just going to do the difference of that, which is 0.2. So your percentage of more than 3 iPads being sold is 20%. The next question is, on what percentage of days were 2 or more iPads being sold? So the first thing you want to look at is the percentage of 2 or less iPads being sold. So you're going to look at this column where 2 iPads were sold. You're going to go across to your cumulative relative frequency, because it's an accumulation of 0, 1, and 2. So that number is 0.54, but it's not asking for where 2, the question is not asking for if 2 or less iPads were sold that day. It's asking the percentage that 2 or more iPads were sold that day. So you're going to go ahead and do 1 minus that, because again, you have the probability of everything happening overall is 1, and you want to take out where 2 or less iPads were sold, because you want everything that's above that. So just be 1 minus 0.54, which is 0.46. So that is kind of like a brief overview of like what relative and cumulative relative frequency are. Usually you're going to have to make this table yourself. Sometimes you'll be given it. But like I said, it's really simple. We just like went through that. So it shouldn't be too hard to make yourself. And then after you make the table, all your calculations are pretty straightforward from there, as you can see. So we're just going to go over like a few types of like data and just rationalize if it's discrete or continuous. So the first one is like the number of students in a class. It's like assuming you walk into the class and you can count every single person in that class, that is considered discrete data because it's countable. It's going to end on like a whole number. In the next example, I guess I already used the word weight, but like the weight of like a dog. So like I said, you could put your dog like on a scale, and yes, it'll bring up a number that like could be rounded to be whole or like rounded to another decimal place, but we can't exactly measure the weight of the dog perfectly and get like a number that's like absolutely accurate without like rounding or like taking it out to a certain amount of decimal places. So that's considered continuous. The next thing we're going to go into is constructing frequency distribution with grouped quantitative data. An equation you probably have seen in class is, what this means is 2 to the k, which is the number of like groups or classes or something like that, you should have seen this before, is greater than n, which is the number of data points. I'm just going to go into an example because I think that's the best way to explain this. So the question I have is, what is the appropriate number of classes if you have 80 data points? So the number you're given is 80. There's 80 data points, which is n. N is always the number of data points you have. That's like gonna stay true in most statistics classes you'll take. So if you see this equation and you don't know what that is, just assume that like n is always that. So n is 80. And then we're trying to figure out what is the appropriate number of classes or the appropriate number of groups for 80 to split 80 into. And that number is k. And that'll like always be k in this equation. So how you would do that is you would do 2 to the k. You can use the sign because this is just saying that like you don't want to have more groups for this number. How you would go ahead and do this is you would take the log of both sides, the log of 2k, and then the log of 80 on this side. I'm not going to go ahead and solve it. I'm just going to keep it as log of 80, but you can just put that in your calculator. When you take the log of something, that'll bring the k down. So it'll be k times log of 2. Sorry, that should be like that. And you still have this on this side, a log of 80. So you're going to have this, and then you're just going to divide by the log of 2 on both sides. And that'll be k, which is your number of classes, 6.32. So when you get this number, when you do the log of 80 divided by the log of 2, that gives you this number. And you're always going to round this number up. So you're going to round it up to 7. And that would be the appropriate number of classes if you have 80 data points. When you have 80 data points, you don't want more than 7 classes, and that's like the max number of classes you can have. So that was an example of it. That's kind of how you do it. We're just going to go over and do another example of it. What is the appropriate width of each of these classes if the max data value is 45,000 and the min is 10,000. So the first thing so this is the minimum. It goes from 10,000 to 45,000. So the first thing you're going to want to do is find the range, which is your highest value over your lowest value, and that's what they gave us. So you're going to do 45,000 minus 10,000. And because you want to know how the appropriate width, and you want each of them to be separated equally, you're just going to take the range, and divide that by 7 because you want 7 classes. And that value is going to be 5,000. So that would be the appropriate width of each of your 7 classes. So the next thing we're going to go into is contingency tables. Here is your contingency table. Contingency tables just tell us like how many times something happens, and they usually break off like people into like groups. So it's another type of like frequency table you're going to see. So the best way for me to describe that is just to go into some questions about it. So here you have a contingency table for 7-Eleven customers. It shows the payment they use, if they're female, if they're male, and the total. So it just tells us a little bit of data. So the first question is, what is the common and least common form of data? So like I said, a contingency table is just like a frequency table. So it's asking for what is the most common form of payment. So you have cash, you have credit, and you have debit. And when you look across these tables, the total for cash is 7, the total for credit is 9, the total for debit is 4. And the total of everyone would be 20. So the most common form of payment would be 9 because it has the highest frequency. So that's how you interpret that question off the contingency table. The second one is asking what is the least common form of data. So if it's least common, you want the lowest number. So again, you look at the cash is 7, credit is 9, debit is 4. The least common form of payment is debit because the lowest number is 4. And then the last question that's asking is what is the probability that a randomly selected customer from this group is male and paying with cash. So what this is it wants you to find the probability of someone who is male and paying in cash. So how you would do that is on the probability you always want, so you want this on top and your total on the bottom because it's asking what is the probability of from all these customers, your customer is male and paying with cash. So you can also, so I wrote it like this, but you can also see it as the intersection, which is the intersection of people who are paying with cash and male. So you're going to go across this table and you're going to find your top value or number. And in this case, you are looking for someone who's male, so you're looking at this column that's male. And these are your people who are male, M. And then you're going to want to look across and see who's paying with cash. So this column shows everyone who's paying with cash. So the intersection of the 2 points is 5. So that would be your number at the top. And then because you want the probability of that person being picked out of every single customer, you want your total, which is right here, which is 20. So it's 5 divided by 20, 5%. So that's kind of how you interpret a contingency table. Like I said, it's just like a frequency table. I can go over a little bit how to interpret it again. So this would just be like people who are female, who are paying with cash, the frequency for that, the people who are paying with credit, and the people who are paying for debit. So this is just like a multi-column frequency table, similar to the one we did earlier, except it just shows us a little bit more data. Really helped you know and understand statistics and frequencies a little bit more. If you have any questions, just feel free to pop by the Econ Tutoring Center and we can help you. Thank you.